Assalamualaikum and good morning to Dr. Mazna. I'm the representative for our group, which is Group 5. We have conducted experiment electroplating iron nails using copper with different voltage. Assalamualaikum to Dr. Mazna. I'm the first presenter of my group. My name is Siti Norhana binti Bahari with ID number SA22078. So I will give introduction about this experiment. First of all, by the slide that I show, this experiment explores the electroplating process where a thin layer of copper is deposited onto an iron nail using an electrical current. We will investigate the impact of varying voltage on the amount and quality of copper deposited on the nail. Our objective of this experiment is to measure the thickness of the copper coating at different voltages. Now, I'm going to explain electroplating basics. Electroplating utilizes an electrochemical process to transfer metal ions from an electrolyte solution to a cathode. The target object receiving the plating. In this experiment, the iron nail acts as the cathode, while a copper electrode will act as the anode. An electrolyte solution, typically a copper sulfate solution, serves as the medium for ion transfer. By applying a voltage between the anode and cathode, copper ions from the electrolyte solution are attracted to the negatively charged ion, the cathode, and reduced to form a copper metal layer. This experiment also focused on how different voltage applied during electroplating affect the copper deposition on the iron nail. Generally, a higher voltage can increase the current flowing through the circuit. According to Faraday's law of electrolysis, the amount of metal deposited is directly proportional to the amount of charge passed through the solution. Therefore, we expect an increase in voltage to lead to a greater amount of copper being deposited on the iron nail. So the hypothesis for this experiment, as the applied voltage increases, the amount of copper deposited on the iron nail will also increase. And this experiment will allow us to gain practical experience with electroplating and explore how voltage plays a crucial role in this process. The materials for the experiment are iron nail, distilled water, copper sulfate, dry and dry cell battery. Also, the equipment are hot plate, magnetic stirrer, sandpaper, crocodile clip, copper wire, and 600 ml beaker, thermometer, also spatula. Now, before I show the video of our experiment, I will brief the methodology for this experiment. First step is 0.1 molar copper sulfate solution was prepared by dissolving 12.5 gram of copper sulfate into 500 ml hot distilled water to increase solubility. And the solution was stirred using spatula or magnetic stirrer to make sure all the copper sulfate was dissolved completely. Second, iron nails were sanded with sandpaper to remove dirt and rust. The initial mass of iron nails were weighed and recorded. The third one, apparatus was set up as diagram below. Copper wire was connected to positive terminal, which is anode of the battery, and iron nail was connected to negative terminal, which is cathode of the battery. The fourth step is both the iron nail and copper electrode were submerged into the solution for 10 minutes. After 10 minutes, both iron nail and copper wire were taken out and the iron nail was let to dry. The mass of dried iron nail was weighed and recorded. And the last step is this process was repeated using another iron nails and different voltage of battery, which is 3.0 volt and 9.0 volt. Now that's all from me, and I will show our experiment video. After that, I will pass it to the next presenter. Hope you all enjoy our video.
SA22027. So now I will continue for the result part. From this table, we can see that the initial weight of ionomer before electroplating for 1.5 volt is 1.4957, for 3.0 volt is 1.5316, and for 9.0 volt is 1.5428. The final weight of ionomer after electroplating for 1.5 volt is 1.4992. For 3.0 volt is 1.5370, and for 9.0 volt is 1.5524. So by using the final weight and the initial weight, we can calculate the change in weight of ionomer. So the first one is 1.5 volt. The change in weight of ionomer is 0.0035, and the second one, 3.0 volt. The change in weight of ionomer is 0.0054, and the last one, 9.0 volt. The change in weight of ionomer is 0.0096. So this is the graph of change in weight of ionomer against voltage. From this graph, we can clearly see that when the voltage increased from 1.5 volt to 9 volt, the change in weight of ionomer also increased. That's all from me. Thank you.
Hello, I am Fatir Ilham Firdaus bin Rahman with the matrix number SA22108. Will present to you the discussion of our project. To begin with, the data collected clearly shows that the amount of copper deposited on the iron nail grows in proportion to the voltage applied. This is compatible and consistent with the electrochemical principle that states that when voltage increases, the reduction rate of copper ions also increases, resulting in more substantial metal deposition. During our experiment, we must take a few precautions to ensure that we achieve the desired result. For example, we must prevent the anode and cathode from touching each other. Aside from that, we need to ensure that the crocodile clip that attached to both ends of the samples is not submerged in the solution. During the oxidation process at the anode, which involve a copper electrode, solid copper wire Cu loses electrons and dissolve into the electrolyte as copper ions Cu2+. The chemical reaction for this process is represented by the equation Cu solid to form Cu2 plus aqueous plus 2E minus. At the cathode, which involve an iron nail, the reduction process will occur. Copper ions Cu2 plus in the electrolyte gain electrons and are reduced to solid copper Cu, which then deposits on the iron nail. The chemical reaction for this process is given by the equation Cu2 plus aqueous plus 2E minus to form Cu solid. That's all for me. Thank you.
My name is Nur Eliana Sofia binti Muhammad Kamel and my ID number is SA22083. For the conclusion, the amount of copper deposit on the iron nail increased with the applied voltage. At 1.5 volt, the changes in rate was 0.0035 gram. At 3.0 volt, the changes in weight was 0.0054 gram, and at 9.0 volt, the changes in weight was 0.0096 gram. This indicates that higher voltage enhance the rate of copper ion reduction and deposition on the cathode. In conclusion, the experiment demonstrates that voltage plays a critical role in the electroplating process, affecting both of the rate of copper deposition and the quality of the resulting coating.